So let's talk about 5 misconceptions, or maybe 5 things that every compressor owner should know. I'll start with you, Mickey. Compressed air is free, right?
Oh yeah, it's really free. Without question, it's the most expensive utility in any manufacturing, based on energy input versus energy out. And it takes roughly 8 horsepower at the at the electric motor to generate 1 horsepower of compressed air. That's if you have efficient uses of compressed air, meaning an air tool isn't a $10 or $20 or $50 air tool, it's just a fan, okay? So, also the other issue becomes one of wasted air. People think air is free, so what they do is they sweep the floor with it, they clean their clothes off with it, they have an open nozzle because, yeah, it's free, don't worry about it. So when you look at that conversion factor to start with, okay, that's bad to begin with. But then improper uses of air is just air is being thrown out there. So there's numbers that have been thrown around, and every time you look at it, it's something different. But roughly, there are plants that I've gone in there's 100 horsepower worth of leaks. Okay, that's not right. Okay, somebody's got to take care of that problem. But there's other issues that come up. One is the percentage of wasted air. How much wasted air the average manufacturing facility has, and that's somewhere around 30% of their energy.
On average.
On average. Okay, could be greater, but that's on average. And I went to a school years and years ago, and I wish I remembered the number. But if manufacturing facilities would just use their compressed air properly, I can't remember how many power plants in the United States could be shut down, but it was way more than 5 or 6. Okay, it was way up there. So it's a matter of extreme ecological side of it. If you're wasting energy, we have to produce more energy, right? So we have a save our planet type of situation. On the other hand, it's costly.
It is, yeah. Another misconception I get often in the sales field out there is bigger is better.
Bigger is better.
Give me the biggest compressor you got. And being involved here at Fluid-Aire, doing a lot of the data analysis and data reporting and such, it's staggering sometimes to see the loads on some of these compressor systems. Just did one the other day. A company bought a 150 horsepower compressor because it was an excellent deal. Little did they know that 80% of their costs over the lifetime of a compressor is the energy to operate it. They were operating this compressor at about a 25% load on average. It was a great deal until I showed them what the energy cost was to operate the compressor annually. It wasn't such a great deal. So, yeah.
I've got an example of that same thing. I had a guy who I was quoting a 25 horsepower air compressor, and the owner of the company saw something at an auction, so bought I don't remember the manufacturer right now. It may have been Worthington, just going back a ways. But he bought a 150 horsepower Worthington water-cooled compressor. He bought it, he installed it. I don't know what it cost him to install it. The end result is it wasn't more than 2 months later I got a phone call. You got to solve our problem. I mean, my water costs are going through the roof. My energy costs is ridiculous. So so we went in and solved the problem. But people need to rely on people like us to make those decisions, doing what Brad just mentioned, doing some grafting of what their airflow really is and what their energy costs are. So that opens people's eyes.
Yeah, I think a fun fact that everyone should know, the rule of thumb, is the cost of one CFM of compressed air. So the simple rule of thumb is 1 CFM per shift at 10 cents per kW costs about $35. So you multiply that times 2 for 2 shifts, 3 for 3 shifts, and then multiply times 4.2 if you're running 24/7. So yeah, it's an interesting number to calculate.
That is.
What would you say, Joe? What's a misconception or something every compressed air user should know?
Well, I found it interesting over the years on how some people will just have locked down more pressure, higher pressure is better. And that also leads in the higher cost of operation. So if your plant only requires 90 PSI, going to 130 isn't a benefit for you, it's a cost.
So some users push their pressure there because their machines operate better. Maybe the machines are only operating at 90 PSI, but they have to get the pressure up to that 125, 130 to get them to operate. Tell our audience a bit about what they could do to maybe lower the plant pressure. What are some things they could do in the compressor room or the piping?
Well, yeah, piping is key. Look at the way your facility's piped and that it's piped most efficient. So you don't have a pressure drop across the plant to overcome that loss.
That's good. So
Receiver tank locations are key.
yeah, size of our filters.
Size.
You know, there's a balance between going too big on a filter and being just right. We often see couplers used in places they shouldn't be used. If it's a fixed machine, hardwire it or hard pipe it or hard direct connect it rather than using that coupler as you would with an electrical connection. Treat it the same way. Those couplers are very, very restrictive, and I've seen up to 10 to 15 psi pressure drop. The other thing too is a CNC machine uses a large pulse of air for a very short, split second during its tool change. Well, they will say that the average flow in the manual is 6 to 10 CFM, but that pulse that happens is for a split second and could be, 100 CF plus during that shot. It needs to get the air to that pulse or that requirement instantaneously. If it doesn't, you have that low pressure alarm that pops up. So
I've got another real world experience. Plant in South Dakota makes doors. Called me in after I did a seminar at a local college, and they called me in to take a look at what's going on. They said, we need to buy a bigger compressor. What do you mean? They had a bunch of Ingersoll ran 150 horsepower compressors running at about 125 psi. We got to get one that's 150 psi. We got it. We just can't work with these. So I went and took a look at what's going on, and I was measuring pressures in the headers, still 125 all over the place. We had come on down to the location where these air tools are being run. And one of the things that I did and still do from time to time is take a gauge and a T and put it into the air tool and put your disconnect on the other side. So I got 125 pounds in that header. They had a manifold underneath the assembly line with a lot of disconnects again coming out. I pulled the trigger on that thing, and it was 80 pounds. 125 in the line, 80 pounds there. We cleaned up all the hoses to make them larger. The hose leading into their manifold, bigger, not a 3/8 hose, a 1/2 inch hose or whatever, 3/4 I think is what we used. It'll decrease the amount of disconnects, only one at the tool only. They ended up with 110 psi or 115 psi at the tool. Now we lowered the pressure in the plant, which, as we talked about earlier, every 2 psi drop is 1% of your energy. So instead of going out and buying another 150, 200 horsepower air compressor at 150 psi, we turned compressors off and saved the customer an enormous amount of money and sold them nothing.
this leads me to a misconception that you could speak to, Dad. So misconception number 4 is you should plumb your compressor system together with the pipe size that comes off the compressor.
Yeah,
So that kind of speaks to what Mickey's just talking about here.
Yeah.
I'm thinking of regulators. We refer to
Right.
that last 30 feet as the dirty 30.
Right.
Go ahead.
Yeah, well, it's the pipe size on the compressor discharge varies by horsepower. I mean, a 20 horsepower might have a 3/4 inch, opening, 3/4 inch pipe. A 50 horse or 30 horse might be a 1 inch. A 50 horse is an inch and a half. Now, these are exact numbers I've seen on machines.
Yeah, that's 1.5, right?
150 horse might be a 2 inch. That's fine for that point in the system, because if you take a 1 inch open orifice and feed it with 100 psi of air, that passes hundreds
You'd
of
drain a
CFM
plant.
of air.
It'd absolutely
Hundreds
drain a plant.
at that point. But you can't stay with that pipe size if you plan on running pipe any great distance around a plant or a loop or system, or, some of these plants are 100,000 square foot buildings, 200,000 square foot. We've got some buildings up in Kenosha that are 1.1 million square feet buildings. Well, if you ran that 3/4 inch pipe off of a 20 horse compressor for that mile worth of pipe, by the time you get around and you're going to have pressure drop, because pipe is resistant to airflow, and air hose is even more resistant to airflow. So, and really, I cringe when I see a guy who piped up his plant with air hose strung through the rafters all over the whole place. I mean, that's horrible. And but you need to size your pipe according to distance and amount of pipe. So the farther you go, the bigger the pipe you need to overcome pressure drop, because of the natural internal resistance of airflow within a pipe. And you need to maintain a certain velocity in the pipe, and there's a lot of dynamics that go into it. There's a lot of physics behind it. There are charts that make it very easy for speccing out pipe size. The charts are based on CFM airflow and CFM airflow expected and at what pressure in the plant. And then they give you recommended sizes for, number of feet that's involved. So it's more than just taking a 3/4 inch pipe off your compressor and thinking that that's going to be sufficient. It might be if your plant is, if you're piping up your garage or, a very small area, it might be sufficient. But if you're going to be going, 100 feet this way, 100 feet that way, and 100 feet back, well, then you have to increase your pipe size maybe up to 1.25 inches or 1.5 inches,
One of the analogies I've always used, and I think I shared that with you one day, is that if you had a garden hose sitting in your front yard and you're trying to water your front yard, you can cover a given area, right? You add 2 hoses to that and go to your backyard, you're not covering nearly as much area. All the restrictions of that. The fire department has the same water pressure you got, but they got a hose this big and they're shooting over top of the building, okay? The end result is just what you said. Too small diameter, too much restriction. You can't flow through that. So you have to compensate for that, you have to have a larger pipe or a larger system.
So this is the one area where bigger is better.
Yeah, well, yeah, right.
talking
Yeah, I mean, you
compressor.
can't hurt by putting too much in, but it's going to be costly.
It's going to be costly. Yeah, and I suppose that's another misconception out there is I'm just going to put a massive header that's going to become my air tank.
Right.
It's from an economical standpoint, it does not make sense. Purchasing storage, standalone storage is by far much less.
Do you ever work out a length of pipe that's you go pi r squared times the length and find out how many actual cubic feet or gallons or whatever you want to go in there? It's minimal, especially even in 2-inch pipe.
Yeah, 2 inch and lower doesn't make sense.
Yeah,
When you get to the larger size, it does add up.
Yeah.
I just wanted to touch on a point about pipe sizes, as we just discussed. Regulators is another very resistive component in a compressed air system. We often see customers will put, or even OEM machine manufacturers will put in a regulator based on a cylinder size or the port size. It could be a very inappropriate way of sizing it. You really need to look at the flow chart, the characteristics of the flow of that regulator. And there's a performance curve that
it's called
droop. Is that what they call it? Yeah. Okay. The pressure drops off extremely quickly.
Oh, absolutely.
I mean, as soon as you start to flow some compressed air, it drops it off very quickly. So you need to look at the performance curve when you're.
Well, how you compensate for that is there are spring operated regulators, okay? And those are the ones that you sit here, they drop there and it's 100 pounds, it drops down to 75 pounds, wiggles a little bit and go back to 100 pounds again. Or there is diaphragm, air compensated types, they're called, I'm trying to remember now what the term is.
Pilot operated.
Pilot operated regulators. But they will sit at 100 and move maybe 3 or 4 pounds, okay? And those types of regulators are the ones you should use in those locations so you don't overpressurize the system to get just across the regulator.
That's good. So those are components that we use for point of use requirements or machine by machine. Then we see some guys put regulators back by their compressor area. That's probably the worst spot to put them, unless you're a small system. But when you get into larger, you want to use mass flow type regulators that are measuring the pressure on either side and using a modulating butterfly valve. So the pressure drop across that is very low, PSI or even less. So.
You don't want to run your plant at higher pressure. Again, we said that we're going to say this more than once. Every 2 PSI is 1% of your total energy. If you can run your plant at 100, but now you're running it at 125, just because that 125 is costing you 12.5% of your energy.
And oftentimes you find that if a customer finds he has to keep increasing his pressure from 1 year to the next, usually tells you what? Your equipment that you're running with that compressed air, be it a CNC or air tools or something, is beginning to degrade internally. In other words, the air cylinders, the seals, are beginning to degrade, or they're not being lubricated, so it takes more pressure to move that cylinder back and forth. A lot of these machines have air lubricators on it for the pneumatic components. Well, air lubricators, they run out of oil and no one knows that device is even there or what it's for. No one fills it back up again. So a year from now, all those cylinders they're just hard to move. So we crank up the pressure. So we get that cylinder to move. Or on the other side is like air solenoid valves. They start leaking internally. You don't hear the leak internally. So that leak causes a pressure drop internally in the machine. You don't hear it because a lot of those solenoid valves on the exhaust port, they have a muffler. So you don't hear it. And especially with all the other background noise. And so now they've got pressure drop because of internal leakage. So what do? We crank up the pressure. What does that do? The higher the pressure, the more you're going to leak. The more air, the more CFM that you're going to lose. So it's these are all misconceptions that we need more pressure. Well, why? Let's go back, find out why you all of a sudden need more air.
All of a sudden it made me think of variable speed air compressors, because one thing about variable speed air compressors is that you can put one in, unlike a load unload that has to go through 2 pressure points. And again, a variable speed air compressor will save you energy because the lower the CFM load, the less you're going to pay in energy. It's not true about every air compressor. But you can dial in pressure 1 pound at a time. And so you can find out where your pressure point is. Meaning that, okay, let's start at 125 on Monday. But on Wednesday, we're going to 120. And on the following Monday, we're going to 115. And we're dialing it down to find out where our problems are. Once we find that problem, let's go fix it. It may not be a real issue. Let's find out who's complaining out there. If that person out there is complaining, I don't have enough pressure, and you find out we just had the same issue, that you got too many disconnects, you got all this stuff, and he doesn't have it, well, let's fix the holes. Now let's start dialing it down again. And I guarantee you, I want to say 90%, but there are many plants out there that are overpressurized. Mm-hmm. And I said the advent of the variable speed compressors really helps you dial in on that pressure that you need.
That's really good. The 5th point I would like to add to this is something that every customer should know is training on compressed air is important. We talked about data logging earlier. I often like to do in my walkthroughs is train the customer and encourage him to train his staff in operation meetings or maintenance meetings or whatever on leakage, and what you were just referring to is to dialing down the pressure. That compressed air is expensive, and largely these conversations about air systems is about energy, because 80% of the cost is lifetime cost for compressor is the energy being operated. So training, whether it's data logging or explain to them that compressed air costs this much, that if you can hear it, it's at least 1 CFM that you should fix it. The ROI is extremely quick. Maybe you can add to that.
No, obviously anything you hear you fix. But we can go around with sonic leak detectors and find even the smallest leaks. They tend to add up, but if you can hear it, you can walk through your plant on a Saturday morning when just turn your air compressor on and take a listen to what is actually leaking. There's just, you'll hear them, okay? And the ones you can hear need to be fixed. We can, like I said, you can get a lot finer than that and get down to all the little leaks, but the big ones are the ones that cost you the money.
Yeah, if you consider a coupler, good quality coupler set is what, about $13, $15 for a good 8-ball coupler set, and 1 CFM is costing you $35 in a single shift. It's pretty fast ROI, isn't it? Have your maintenance department get that repaired.
Talking about couplers, most companies have 3/8-inch couplers or 1/4-inch couplers, so they use them all over the plant, no matter what it is. Okay, boy, there are 1/2-inch couplers out there, and they're using a smaller 1/4-inch coupler when it should be a 1/2-inch. Okay, and the issue becomes one: you have to know that there is a difference. That pressure drop across that is enormous. Yeah. Just a standard coupler flowing 20 cubic feet is going to have 3 or 4 pound drop.
Yeah. So you can't measure it. You can't manage it if you don't measure it.
That's right.
So data logging is very important. I would encourage any compressed air user, especially over 50 horsepower, to have Fluid-Aire or your current service provider do that annually. Because I don't know. Walking through a plant, right. I certainly don't know.
It also gives you a baseline, Brad. That's if XYZ, if you have 100 CFM that you're using on day one, and a year from now you're using 150 CFM, and you haven't added any equipment to your plant, well, you're wasting air.
Guess what? Yeah.
So if you're struggling on your bottom line, let us help you fix your air leaks. It'll put it right to the bottom.
I guess I just want to add one more point. On the misconceptions. So this might be point numbers 5A or maybe 6. I'm not sure how we want to list it. But one of the biggest misconceptions is we're going to put our air compressor in this tiny little room. We're going to turn the lights off, close the door, and just go to town on the business. Compressed air is necessary. You might even want to call it a necessary evil. But if you don't have compressed air, you don't have anything. Your CNCs won't work, your air tools won't work. You might as well just turn the lights off in the whole plant and go home. So you go out and buy a $1.5 million CNC machine, and it requires compressed air to run it. You proudly display that machine in the middle of your production floor for everybody to see. But the necessary ingredient to make that machine operate is put in a small room, the door shut, and the lights out. Why do you do that? Your compressor is actually almost more important than your CNC machine, because without the compressor, the CNC doesn't run, right?
Without the compressor, none of your
stuff's
why don't you treat your compressor like really almost the most valuable piece of equipment in your plant, and set it up in a well ventilated, well lit area with enough service room at least 36 inches of space around your dryer, around your compressor, around your tanks, so service can be accessed. If you've got a 150 horsepower compressor and you need to replace the motor on it, how are you going to get it out if that compressor is in a small room with no place for a fork truck to work, no place for an engine hoist to work, no access to that machine?
I'd like to add to that, all of us sitting around this table have been technicians, and we appreciate clean, well-lit, ventilated compressor rooms. And I would also add to that I spend more time in those compressor rooms. When you're
Like
comfortable,
this?
yeah, when you're comfortable, you will spend more time on a customer's machine. So it's really good what you.
Well, the other thing is, you said well ventilated. You start increasing the temperature in your compressor room, you're going to find out that your dryer isn't adequate, and you're going to have water in your plant. It has everything to do with the heat. You're overtaxing the dryer by the heat load that's coming from a compressor that is running hot. So that is, just want to throw that in. It's important that the room is cool just to get rid of moisture. You'll find that, obviously, sometimes people are complaining about modern airlines because their compressor room is not well ventilated.
Yeah.
Okay.
There's so many hidden.
Or their
costs.
dryer isn't oversized to compensate for that.
So there's so many hidden costs in a compressor
Absolutely.
system. When you talked about water in a compressed air system, washing all that lubrication away.
Yeah.
Customers' spool valves on the machines, wearing those good old important cup seals and O-rings, putting flat spots on them. Consumes a lot of energy. It's costly to replace those valves or cylinders.
You can lubricate an air tool, but if you wash it away with water, you got it. The other thing is, if it's still connected to the airline, you got water sitting there overnight. What are you going to have? Pitted, rusty. The end result is you need dry air in a plant, and dry air starts at the air compressor room and the environment that your compressor's in. Okay, and if it is hot, there's certain temperatures that can go beyond and shut off the air compressor, but it's running at a hot temperature, and the dryer's in that room. You need to oversize that dryer to compensate for that extra heat load. And there are correction factors on every single dryer sheet a manufacturer makes them. And if you anticipate that instead of 100-degree ambient condition or air coming out of your air compressor, it becomes 120 degrees going to the dryer. 250 CFM dryer and 250 CFM is not adequate. You need to go to 500. You need to double the size if you go to 120. So it's important to know. It's not that your dryer isn't working, it's that you're giving it too big of a load to start with.